Hello, let's evaluate this integral summation n equal to 1 to infinity integral 0 to 1, right, x power n into 1 minus x whole power n dx, right. Let's take it as I. This can be written as summation n equal to 1 to infinity integral 0 to 1 x into 1 minus x whole power n into dx. So let's consider this f of x function, right. Let this y of x equal to x into 1 minus x, which is x minus x square, right. Then let's see what will happen. Here the integration limits of x is from 0 to 1, right. If it's integral 0 to 1, what will be the highest point here? Y dash of x equal to 1 minus 2x equal to 0, that is x equal to half. When x equal to half, then y will be 1 by 2 minus 1 by 4, which is 1 by 4. As you can see here, y of x is x square, x minus x square. Then how does the graph look like? When x equal to 0, y equal to 0, it passes through the origin. When x equal to half, y is 1 by 4, right? It is a type of like this. X equal to 1 by 2, this is x, this is y, this is x equal to half, this value will be 1 by 4. Because as you can see here, y equal to minus x square plus x, right? I mean, this is ax square plus bx plus c. Here in our case, a is minus 1, right? So it will be curved like this. If a is positive, then the curve will be, if a is positive, then sorry, a is positive, the general case, this will be like this, right? So in this limit, the function x into 1 minus x is in the integral limit 0 to 1, 0 to 1. As you can see here, the highest value of y function is 1 by 4, right? It will not cross 1 by 4, which is less than 1 on x belongs to 0 comma 1 integral. So that is, you can say that this geometric series in n converges uniformly, right? As you can say, it's less than 1 by 4, and you're just integrating x power n into 1 minus x whole power n, and we are doing the summation, right? Because it's converging, now you can just let the summation inside of the integral, which is integral 0 to 1 summation n equal to 1 to infinity x into 1 minus x whole power n dx. As you can see, this is a geometric progression. Now this can be written as integral 0 to 1. The formula for this infinite geometric series is a by 1 minus r, where a is the first term and r is the common ratio. Here the first term will be x into 1 minus x, and r value is 1 minus x into 1 minus x dx. Fine. Then this I is integral 0 to 1 x minus x square by 1 minus x plus x square dx. This can be written as integral 0 to 1. The denominator part is x square minus x plus 1. So let's try to write the numerator in this form, which is, you can write it as minus of x square minus x, right? If you are adding plus 1 here, which is in a way that is minus into plus 1, right? Minus 1, you need to add 1 here to compensate the 1, which is this. Now separate these two integral, which is integral 0 to 1 1 by x square minus x plus 1 dx minus integral 0 to 1 x square minus x plus 1 by x square minus x plus 1 dx. What is, this will get cancelled, right? Then this integral will be, you can just calculate it here. For this case, it will be integral 0 to 1 dx, which is x into integral 0 to 1. This will be 1. Fine. In a way, I is integral 0 to 1 1 by, let's try to write it in the form of a minus b whole square. So this will be x square minus 2 into x into 1 by 2. Then this will give minus x, right? So plus 1 by 2 whole square minus 1 by 2 whole square to compensate the extra 1 by 2 whole square plus 1 into dx. The second integral value is minus 1. So here I is integral 0 to 1 1 by x minus half whole square. Then this will be 1 minus 1 by 4, right? 1 minus 1 by 4, which is 3 by 4. You can write it as root 3 by 2 whole square plus root 3 by 2 whole square to dx minus 1. So you can see it is in the form of 1 by x square plus a square, right? You can take x minus half as t, or you can just apply the formula 1 by x square plus a square is 1 by tan inverse x by. Just let's try to apply the formula directly. 1 by a, right? Then 1 by root 3 by 2, it will be 2 by root 3 into tan inverse x minus half by root 3 by 2 integral 0 to 1 minus 1. Fine. Then this will be I equal to 2 by root 3 into tan inverse of 2 by root 3 into, when x equal to 1, this will be 1 minus half minus tan inverse 2 by root 3 into, when x equal to 0, this will be, when x equal to 0, this will be minus half minus 1, right? Then this is 2 will get cancelled here. Then I is 2 by root 3 into tan inverse 1 by root 3. Here this will become this minus and this minus, because we are taking the values x equal to from 0 to 1, right? Then this will be plus tan inverse 1 by root 3 minus 1. I is 2 by root 3 into, as you know, tan 30 is 1 by root 3, which is pi by 6, right? Then this value will be pi by 6 plus pi by 6, 2 pi by 6 minus 1. 2 ones, 2 threes. Then this will be 2 pi by 3 root 3 minus 1. So finally our solution is summation n equal to 1 to infinity integral 0 to 1 x power n into 1 minus x whole power n dx is 2 pi by 3 root 3 minus 1. This is the solution.